Well, today we're going to do a lab that I stole from a teacher over at Hazelbrook, Rihanna. And it's a great lab. It's called the Law of Conservation of Matter. Have we ever talked about conservation before, or law of any other kind of conservation? I want you to think about maybe back to the forces in motion unit, or maybe you've heard of this law of conservation of matter before. I don't know. But think about it. Kind of, dig into your file cabinet of your brain and see if you can, if you can figure this out. All right, so very simple lab. You're just going to need some baking soda, some vinegar. You're going to need a graduated cylinder, something to scoop up the baking soda, and a balloon, a balloon. So probably the best thing to do first is take and fill up your Erlenmeyer flask with about 25 milliliters of vinegar. So I'm going to just do this with the graduated cylinder, and I'm going to pour this in. You remember bottom of the meniscus and all that other good stuff, Pour that in there. We go, a little bit, a little more, a little more. Where are we at? We're almost there. Just a little more. A little bit more. Okay, there we go. We got 25 milliliters. All right. Then, of course, we made the bottom of the meniscus and all that other good stuff. And pour that in your Erlenmeyer flask. Boy, isn't science fun. All right, so now it's in the Erlenmeyer flask. And then what I need you to do then is you're going to take your balloon and put a scoop of, not a whole lot, but a scoop of baking soda inside the balloon. See, I'm pouring that in there, and I'm probably making a mess. And yeah, you probably will make a mess too. But this is what makes it all. This is what makes science fun, right? All right, so I got a little bit in there. That's good. Just gotta shake that off, get the dust off. We don't want any, get everything down in the bottom of the balloon. It's all good. Okay, now here comes the tricky part. You may need help, I don't know. You're going to put the balloon over, can you see that? I'm putting the balloon over the Erlenmeyer flask opening, like so. All right, can you see that? Okay. Now what I need you to do is you're going to not let any of that baking soda get in there with that vinegar, because you know that's going to be a chemical reaction, right? And you're going to put this on a scale, and you're going to weigh it. And then you're going to pick up the balloon and let the baking soda fall in there with the vinegar. You're going to get a nice chemical reaction. And then I want you to weigh it again and see what happens. What do you think is going to happen? This might be a good time to write a hypothesis, don't you think? And then we're going to let the gas out, and you're going to weigh it again. Now, I recommend you use the same scale every time, because then you don't run into these calibration issues. All right? Got the idea? All right, let's go. Good luck. So now I've got it set up here on the balance, and it's about 132.1 grams. 132.1 grams. Now I'm going to let the baking soda and the vinegar mix here, and then we're going to see what happens. What do you think is going to happen? It's probably a good idea to hold on to the rubber here while this thing inflates. Now the chemical reaction is occurring, and what's happening is we are getting a whole bunch of carbon dioxide being produced, CO2, one of the greenhouse gases. All right, and that reaction looks like it's pretty much well shot. And so I'm going to take my fingers off here just a second here, and we're going to see what's happened to the mass of the container along with the reactants. Oh my gosh, it's 132.1. It didn't change. Is that what you expected? Now I'm going to let out the gas here, and what do you think is going to happen then? Okay, so all we lost there was the gas, and now it's 131.6. Interesting. What do you think that means? Why don't you write that down and make sure, of course, you fill out your data table. Good luck.